No, it's
It's not really. Oh, okay, you can take her seat. She can sit right there. We're exiling her to that table. Hey, good, you're back. Take a seat. How is your knee? It looks better, it's smaller. Yeah. Okay. All right, let's get attendance, and then what we'll do is I'm gonna start going through a proof, and when it gets too boring, it's longish, but it's a simple proof. Then we'll do our quiz. So the quiz is based on what we've been talking for 5 weeks now. And so you're not supposed to, you can fail the quiz and still get full points. So it's that kind of quiz. It's a liberal arts quiz. So the fact is that you sat down and took the quiz, yes.
Sorry, I have a question. It was just meant to be like, not like a question.
Oh, you want to ask me a secret question?
Yeah, secret question. Sorry.
We have to do the secret stuff.
Sorry.
Yes. Okay. It takes like an hour or two. Oh, okay, okay. So if you miss the quiz, that's fine because I'm gonna do quiz. Well, how many people are here? Sit down. Maybe we'll start with the quiz and then you can take that and take off when you need to. Okay. So Carter, I think she might have dropped this class. Okay, Mahmood, Vincent, Thomas, Kay is here, Ellie will be gone. Duncan, we haven't seen him for a few days. Gavin is here, very good. Jake is here. RGB, Chris. Okay, he took off to the bathroom. Mara, I think she is gone now, I think, maybe. Tate is here. Umit and Zara. Sorry, Ryan Strong, the other, no. And then Sophia's side there. Aiden. Emma is missing. No, Ryan Lore is here. Okay, so because Ellie has to leave early, let's do the quiz first. And then we're going to do like maybe 5 to 10 minutes. This is the easiest quiz because you can't fail it. As in, if you fail it, you still don't fail it.
Oh, awesome.
Yeah. This
And
is
it's open though.
this is open, whatever. This is the paradise. Yes. Yes. And put your name on it. I can give you. I love this, but I never do quizzes. This is so exciting. Yes.
Okay.
If you can use ChatGPT. Yeah,
Okay.
Thomas, should I even? Sweet. Yes, because you're in the chill mode, right?
Like May? Yeah.
Back then. I was going to tell you, bring your parents to the pizza party. Yeah. Oh, they didn't come? Oh, okay. So, Levi wants to come, so he missed the email.
No, it's a lower upper bound.
Yeah.
Well, isn't it Supremum?
Oh, this is not the lowest upper bound.
So square root of 2. Unless
No, I don't think that's, no, that's just the upper bound.
Are you here? So look at this real number. If it's square root of 2 is a real number, then it's fine. Okay.
So then we'll say
You guys can ask me questions.
1 is not.
Yeah.
I think because it only gives us 2 options.
Oh, wait, 1 in the set A. 1 in the set A is the lower upper bound.
Yeah.
We're just say LB.
Sure. Cheating is allowed. And
So,
in
yes.
conversation.
Yes.
Sorry, I completely disrupt the question.
So, lower upper bound is A,
So if you have A in the set A.
Oh, wait, let's do it.
Well, yes.
I just realized this question. So is a number in set A an upper bound or a lower, yes or no? And I realized that.
Oh, yeah. So
Why am I
we're
missing?
asking, I'm asking, sorry, is one an upper bound?
Oh,
So that question is one an upper bound or even an LUB? And then just circle the answer no or yes. Maximum element of the set. So
but it's-
maximum means maximum element of the set. Does it have the largest element?
since it's
Yes.
not a lower upper bound, do we still separate it?
So you say no, it isn't.
But it is an upper bound.
No, the one?
Oh, no, it isn't.
No, it isn't.
Oh,
Good,
mine's
good.
really
Yeah.
stupid.
Because it's not color coded.
So is negative two squared. Wait, no, wrong. It's negative one.
Yeah. It's like- So then the GLB is also gonna be-
No, that was going to be square root of two.
No, that's the-
That's the greater low. So that's the, so this is the greater of.
Alright, so for this one where it's A equals 3 to 4, 4 is the lowest upper bound.
And then GLB.
How is it really going?
The backside?
Mhm.
What is the inner?
Like, how are we saying this is?
So look at the set. So it's,
Oh, actually,
No, the
I
lower
think, I
bounds in
know.
this case
So you're just
are
saying anything less than.
negative right, okay.
no, less than square. Yeah.
So from 0 to.
Yeah, and it's a cutoff. Yeah.
Okay, so.
Yes. Yeah.
That's the maximum.
Well, the maximum of A is.
So all of them.
Square root.
Yeah.
Let's just do it.
Yes, so the lower bounds of A are negative one. Negative two, and then.
I think these are two separate questions. What's the lower bounds of the set?
Yeah.
And the next question is the maximum of A.
Wait, how is the GLB squared root of two?
Oh, GLB is the square root of two. GLB is negative one. Because it's the. Because
I think you're right.
yeah, the lower of the bound is negative.
Right, okay, so
And
negative
square.
one. So the maximum greatest of bound. For the first one?
But I'm saying the maximum of A. What's the largest thing A?
Great, great.
That's where.
I would agree with that if it wasn't.
I think those are two separate questions.
Yeah, I think I.
Mhm.
So I just wanted to clarify, for this question here, are these like, is this like an altogether kind of question?
Also, so GLB is saying You just did the upper bounds. How about the lower bounds? Yes.
Yeah, and then, so maximum angle, right, that's. just
Would
the
be
set, right? Not
in the set, the elements in
Oh,
the
okay,
set.
so this is square root of two.
Yes, very good.
Okay.
It's not in the set, so it doesn't exist.
But
Because say just leave it empty.
Okay.
Yeah. So if a maximum minimum doesn't exist, leave it empty. Right. Yeah.
Oh, like a maximum of this side. We have the same.
But a maximum element of the set.
There's some.
No, there's always a bigger number to the right. As you go towards the right, you're always going to find. As you go towards two, there's always a larger number.
But
inside
an upper
the
bound
set.
has to.
Yeah, that's what I'm saying. So that's what I thought.
But then it's like, it's.
Oh, that's what you're trying to say,
It's
yeah.
upper bound of the
It's
set.
more than you say.
Yeah, that's what I'm just saying.
Lower
That's
upper
what I'm
bound.
urban of the side.
Yeah.
We were like,
It's kind of like a weird.
yeah, it's just, it has to be less.
I don't
than
think
There's no
so.
terminology.
We're like lower upper bound is what we have. Does that mean that pi is also? Yeah. So, sorry. No.
Yes, yeah, so it would
I
be towards the
understand.
right.
Okay, so the upper
And
bound
these
is
are
set
the two lower bounds, right?
B.
No, yeah, towards the right are the greater numbers.
And the lower bound,
You
the
guys
lower
put
upper
all-
bound is two.
But it's not.
And then make sure I don't mess it up.
Greatest lower bound.
Negative one. Yeah.
So.
Negative one. Or, no, it's negative one.
Yeah.
Because it's, so why does the upper bound, oh, I just thought it was the lowest bound. No, okay, so you see the, location? Yeah. So this says that this doesn't equal two, so this two isn't in the set, but this does equal two. Well, it's basically, it's kind of like imagine so I took a math lesson. Imagine there's like an infinite amount of numbers here, like 4, 2, like 1.9, 1.99, 1.99. And so you're going to have all of those numbers in the set, but you'll never have two. So it's negative. Yeah. And then just all the lower bounds and stuff. Negative 1 is the maximum, right? Oh wait, no, that's the different thing. Yeah, that's okay. Low bounds, negative 1, negative 2, negative 3. So negative 1, negative 2.
Might be a natural
And okay.
You never know. Oh, you've taken a class like this before? Which one? Real analysis?
I've taken the real analysis. Yeah. It was
No,
my
maximum,
freshman year.
the maximum.
So you were like gifted in mathematics and then.
Like I really struggle with like math, I understand pretty well.
So you're a pure math person, this. I hate applied math.
I really like
Oh, okay. Oh, you are that.
but like algebra, I really
Same thing what Thomas was saying that. Yeah. What? Hmm.
was tough because like
Hmm.
and
Hmm.
then everyone was we're gonna get nowhere. I don't want to do this anymore.
Yes.
I can show you the meet at 1:55. I just want to let you know that I.
Yeah. Don't forget to leave. Yeah.
It's like. It's like function FA from set A to a set B, subset this. But then I actually need to add something to this because you didn't initially do it in the definition. But like stuff like this is for a vocab quiz. I took this.
See, you're really enjoying my class now, aren't you?
Yeah, let's find out. There's actually, oh wait.
Hmm.
This is a square root.
Okay.
But so x, so 0 is in the set. So it could be 0.
Ellie, 0? Is it in the set? No, look at it. It's round brackets. Square bracket means it's in the set. And therefore, It's the cutoff point for,
How supremum does
it
it?
exists, but not on our line.
Okay.
It's a placeholder. The 0 says that's the gap where the square root of 2 would have been if square root of 2 was a rational number, but it isn't. So it's not, we don't even factor it in. So we go, there is no supremum. To the left of it is the set. All the elements of the set are between 0 is not in the set, and square root of 2 is not in the set. Yes.
That if you did like x squared less than 2 and then you made it.
Right. So that was.
What did there?
Oh, because the conversation was in the definition of the set. You can't put in real numbers because you're defining a set on rational numbers only. So therefore, what we do is we do x squared less than 2. So the whole thing about this is that if the supremum is square root of 2, but it doesn't exist in the rational numbers. So there's a hole here. Yep, right here. You put your name? Good. Thank you. So I'll see you Wednesday, hopefully.
Yeah, Wednesday.
Math major.
In theory, if we didn't know.
Say that again?
In theory, if we didn't know what the minimum was, would you tell us? The greater.
The greatest lower
Because
bound.
we know. We just want to-
Oh, yeah. Okay. Yeah. And infimum sounds like a weird name. Yeah. Yeah. No. Oh, for this one? Hey, RGB for this in infimum is 0 for the last one, right? Yeah. You have a question? Yes.
Okay, so we're just wondering if over here, so like this would be the set and
Yes.
everything after is like the upper bounds, right?
Yes.
Okay.
Yeah. And square root of 2 cannot be because it's a Q. You done, Mohammed? You guys can discuss and figure out if you fucked up. Or what's your major, Gavin? Oh, so you should be. This is useful for you. Eventually, you're gonna hit math in your life.
I'm good right now. I don't understand.
Which class? What is it called?
Doing intro statistics, computer application.
Oh.
It's like a lot of coding.
And they go, oh, you don't need anything. Just take the class, and you're like, what? Yeah. Shit. So you're putting in hours to survive in that class? Good, good. Yeah. So this is again the fun class then? Yeah. Okay. Way fucking easy. Yes. So you guys are almost at the last one. Very good. Oh, okay. Very good. You guys are too advanced. Out of my class. I'll have to bring in some really difficult poetry to fuck you guys over. But Chris gets everything, so I can't even use that. You're really good at that shit. Yeah, he's really good at figuring out what it means way before anybody else. Yeah, he's got a. But good thing you're not majoring in that shit. Yeah. Yeah. Umid, you good? Any questions?
It's talking about like of the set A, is it like talking about only
Yes, from there to yep.
Okay.
Yeah, yeah. And then because to the right there's always going to be something. Yeah. Yeah.
Well, they probably have a lot of
Okay, yes.
set.
Hmm?
I don't know how. Like in this, like zero is.
Okay, so oh, sorry. So you're saying what's the so this is yes, that is 2 is correct.
And this is zero.
This is 0, yes.
And then does the implement 7 set no?
Yes, good.
And then does on 6 does on 6.
Yes. Yeah, you got it right. Unless I got it wrong. So you're done? Okay, cool. You could just oh no, yeah. You guys keep this because she's leaving. And then I'm gonna go over the answers right now. All right, folks. How's the middle table? Are you guys ready? Can I go over the are you on the 4th one or okay, finish it up and then it was supposed to be a 10-minute thing. All right. Well, good luck with your job. Don't work hard, slack. No, don't do that. Ah. Oh, obviously, it's America.
Oh, and then are you doing the math stuff for
Saturday, yes. And I'll send out an email.
Did you send out the room number?
Yes, I did that last time too, and I'll do it again.
Okay, awesome.
And you're welcome to come eat and yeah. People are taking this seriously. Good. I had a terrible class last year. Bunch of haters of math. We have to become keep it with you guys. So I'm gonna go over and then you can just put you'll have straight ticks on the left. So you're grading your so on the left hand side, right, where it says so let's start with here with this set. So the set is from -1. The left hand point is not included. Square root of 2 is included in set A. Yes, and then in your in the quiz, I have the other notation, the set builder notation as well to express that. All right, question number 1. List upper bounds of set A, the ones that are indicated. How many upper bounds are there? There are millions and millions of upper bounds all the way to the right to infinity. I just chose to throw some upper bounds up here. So who wants to volunteer? We have RGB. Tell me the upper bounds for set A. Yep. Very good. Is that what everybody wrote? If not, add to it. Because I have to show it to my mother. Your quizzes. Okay, next. Next question is number 1, which falls right here. Is this so because RGB just told me, I forgot to put that one thing in there. RGB said this is an upper bound, this is an upper bound, this is an upper bound, this is an upper bound. Because she didn't mention 1, we're going with RGB that 1 is not an upper bound. Why isn't 1 an upper bound? The definition of upper bound is that it's inside the set and there are elements that are smaller than 1. So it is an upper bound for these guys, but it isn't for the elements to the right of it. So therefore, this is not this is not some new upper bound that we have discovered that is even smaller than square root of 2. So okay, very good. So that's a no. Oh, sorry. LUB or soup. of A is sup is supremum, or LUB is least upper bound. Of these upper bounds, which one is the LUB? Zara group or Sophia? Yes. Very good. So I'm going to put LUB here, upper bound, upper bound, upper bound. Okay. Next question is the supremum of the set A an element of set A? And the answer is yes, because the square bracket tells us it's this endpoint is included as an element. GLB just means greatest lower bound. How many lower bounds are there? Which is a question I didn't ask in the quiz. 2, we have 2. So L lower bound, LB, LB. Which one is the biggest? The numbers towards the right are, so it will be -1, right? Very good. All right, let's move on to number 2. Here we have a set where the left endpoint is included in the set. -1 is an element of the set, while the right endpoint of the set is not indicated by the round bracket. Okay, let's do this. The way I have it set it up here, how many upper bounds do I show here? Somebody list them. Yes, Gavin. 2, 3, and pi. Okay, very good. And then what is the lowest upper bound of the supremum? 2, okay. And is 2 in the set? No, because of that. And then let's do the GLB thing, or infimum is the other word for that. So how many lower bounds, RGB? There's 3. And then which one is the infimum or GLB? -1, and it's in the set. We forgot to do that. What is the maximum element of set A? Let's do that. Square root of 2, because that's the last number there. It's in the set. What is the maximum of set B? And let's pretend that this was the square root of 2, just to kind of make it similar, but it's not in the set. When square root of 2 is not in the set, and it's just the right endpoint, the maximum does not exist, because you can keep going on forever and finding a larger and larger number. Real numbers between any two, there are millions and millions, an infinite number of those things. So, okay, so all the way up to square root of 2, you'll always find a larger number. And therefore, there is no maximum unless it's in the set. Okay, same thing here. Is there a, no, actually wrong. Is there a minimum element of set B? Not the smart table. Umid, since you're alone and lonely over there. -1 is the minimum element because it is in the set and we don't have to worry about going left and left looking for the smallest number. It's sitting right there. Between -1 and the left endpoint -1 and 2, there are millions of numbers, real numbers. All right. So did we miss somebody? Something? No. We did both of these. So let's move on to. So here I'm saying in the quiz, assume that we only deal with rational numbers on this line. If you have a round thing like that, that means this is a place where 5 would have gone. This is where square root of 2 would have fallen in that position, but then we're not thinking about those numbers because we are only dealing with rational numbers, which can be represented as a fraction m over n, where n is not equal to 0. All right, so who wants to tell me how many upper bounds for set C have I represented? 2. Very good. You had 4 and 2, you were hedging. 2, because we're only dealing with this, we can't even see it. We know these are placed this is an irrational number. This is an irrational number. We're dealing with rational numbers. So as it is, 2 is a rational number because 2 over 1, it's a fraction. So is 3. And how many upper bounds does set C have? Millions and zillions and trillions. Okay. Now, does it have a supremum? Set C. And the answer is no. Does set D have a supremum? The answer is like this. Set D, which is also a set of rational numbers, has a supremum too, but that number is not in the there is no maximum of set D because there are infinite numbers of rational numbers going towards the right. 2 is the right endpoint, and it is the supremum for the set D. And why is 2 a supremum? Because it's a rational number. Why wasn't square root of 2 a supremum for this set C, which is a set of rational numbers? Because this is an irrational number. It cannot belong to it. Okay. And then right here we have how many lower bounds? 2. Same thing over here. And then the GLB will be 0, or the infimum. The greatest lower bound here is 0 for both these. Okay, very good. And now I think I'm going to take your exams. And thank you, because I have to do this. Otherwise, it won't be official. Right? You have to give the quiz and take it back. I think I'll email Emma the quiz because I like this. It's Emma. EMMA. Yeah. Not with me. Oh, I'll ask her. Really? She goes by M? She's trying to compete with RGB. She's got 3 letters. Oh, thank you, guys. Use ChatGPT on your exams for that algebra thing. Yeah. Copy and paste. Oh, because it's you can. Oh, the ChatGPT hand will do it for you. No, you can copy paste it and then take pictures and turn that in. All right, folks. Have we run out of time? Oh, and yes, we have. No, we haven't. Is that 37? What a fuck up. Okay. All right. All right, let's do this. So I think we'll just do that topic we did yesterday. So it will be a review for you. Yeah. Okay. You guys took this too seriously, so we had to spend the whole class period. Okay, folks. So I'm introducing a new, and then what? What's his name? Ryan was doing yesterday was you just multiply a negative number through the inequality sign flips, and then you can preserve the distance idea of x minus a or something like that. I'm going to come back to that maybe on Friday. But today we only have 12 minutes. So let's think of what a sequence is. It's the next thing we'll be doing after next week. Or I mean after this week, because I'll just skip forward. So what is a sequence? Sequence is a function that takes a natural number and spits out a real number. RGB, you were saying, why do we need to know about this? We need to know there are things that you can use natural numbers. So natural number can be an input to a function, and then what you get out is not a natural number, but a real number. Okay, so here is a function. It takes n, and n is a natural number. And it spits out a real number, a sub n. That's an f. That's my f. Yes, let me try that again. This is a better f now. So we have a function f. It takes a natural number, and n is a natural number, and spits out a real number. This a sub n is a real number. Okay, so now what do? We better have a formula or something like that, right? So let's pretend the formula for this is you take the natural number and you square it. All right, so what is a of 1? So a of 1 means n is now when n equals 1, the real number a of 1 equals what? This is our formula right here, folks. Ryan says 1. Ryan has just said that. All right, next. Now, what about n equals 2? What is the second term of the sequence that is generated? Ryan says 4. 2 goes in, 2 times 2 is 4. 1 goes in, 1 times 1 is 1. And goes on forever. So now what do we have? We have a sequence. Let's see, this, comma, this, comma, this, going on forever. It's an infinite sequence. Each one of the terms, this is called the term. This is the first term. Second term, right? Term. In sets, we call the things that are inside the sets elements. In a sequence, we call them terms. And in fact, we can put a sequence inside a set as well, but that's another tragic story. And this is the third, and so on. All right, so now we have some idea of what all this is. I'm going to delete all this. So what is a sequence? Sequence is a function that takes a natural number and gives us a, depending on the kind of formula that the sequence has, a real number. Very good. And each of the real numbers are represented like this, a of sub 1, or it could also be in x here. You could say x sub 1, x of 2, like that. Is everybody with me? If not, God help America, because in order to beat the Chinese, we have to do math. Yes, in fact, we cannot compete with them. So we're fucked. So it doesn't matter if we do math or not. All right. So now I was going around and I saw a whiteboard and I saw this thing. And I'm going, oh, this is so exciting. So I'm going to take a point. A point has an x coordinate and a y coordinate. I'm going to put the point right here. What kind of, is this a negative? It's in the negative, right? It's a negative. Let's call it a negative number. All right, so I'm going to call it A1. And then I'm like, what's the next real number? Let's pretend we have real numbers all over this place. I'll explain in a bit. It's actually, each of them is a ordered pair, right? Okay, where do we want to put the next one? Oh, maybe we should do it here. Okay, so I've got A1 here, A2, whatever this number is, this point. Maybe our third term of our sequence is, what is it? Anybody? What's the third term? What's the 0, right? A3 is 0. The value of A3 is 0. I don't know what the value of A1 is. And then we start going above the x-axis. We get another point here, another one here, A4, A5. And then what happens is we have a line here. Let's say the value of this line is 5. So what's happening here? Is the sequence getting close to the value of 5? It was 0 here. If it touches it, it's going to be 5. Maybe it won't touch it. Okay, then what happens? I am now getting very close. I finally got to A. And now what I'm going to say is, after the 6th term, all the terms of the sequence are going to cluster either on top of this line or below this line. Okay, so A7, A6 is after A6, every term is going to be right here. So it's going to be, we got a point here, then another point here, another point here, 3 points here, and then the 4th point here, 7th point, all the way to infinity. So we have a sequence that starts A1, A2, A3, A4, A5. After the 6th term, every term is within what distance of 5? Let's say we decided to say within 1 unit of 5. And so this is our value of our epsilon here. So in other words, after a certain term, all the terms will always be within 1 unit of this line 5. So I call these terms clustering terms. I call this thing threshold term. It's my terminology, so not really, but okay, all right. So now, what's another way to represent all this? Let's do that right here, and then we're done for the day. So we have let's do with the red. We have a real number line. Okay, let's throw in 0 here. Okay, where do I put A1? Is it a negative? We're pretending it's a negative number. So we're gonna do A1 goes here, A2 goes here. After A2, we get a 0 here. So this is our A3. Then we get A4. We get A5. And after A6, let's make this closer here. What does it mean for A3 and A4 to be at this distance and A4 and A5 to be so close? That this number and this number, the difference is smaller. This is A4 is very close to what A5 is. These are two real numbers, while A3 is way smaller than A4. Okay, all right. And then we have our A6. And after A6, all the terms are going to cluster around this number 5. So we have all the terms going here. So here, another one, back here, back down here again. And what are they going to do? They will strictly stay within 1 unit of 5. And so we can, and a 1 unit we're using, so it's going to be 5 plus 1 and 5 minus 1. Or we could call this, let's call 5 what? L for limit. So this sequence of number after a certain term, like in this case, the 6th one, or we call that the uppercase nth term. After this uppercase n, which is a natural number, after that term, all the other following terms will always cluster around the limit. And so sequences have limits, even if the sequence is infinite. This is infinite. It goes on and on and on and on forever. Questions? Yes, everybody gets this? Solid? God help America. And so now what I'm going to do is to help America, I'm going to put epsilon here. Epsilon is the unit 1, right? And then 5 becomes L, 5 becomes L. We'll be doing this for 3 weeks. And then proof about this stuff. Do we have, how much time do we have? 6 minutes, yes. But the poetry. You guys are welcome to come to my 2 other sections in the morning. I just do literature there. No, just kidding. So all your assignments are tied with poetry. So if we do poetry in this class, it's going to be when I'm assigning you your first homework thingy, exam, I call it. Probably, maybe never. So anyway, so what I do is I go over the poem, you give you everything you need, then I go over the thing that we're comparing the poem to from mathematics, give you everything about that, then you just write it up. Because the purpose of this class is to understand how poetry is a thinking object, and so is mathematics and poetry is where thinking happens, because we do comparisons. You take something like this, convert it into something like that. Things are compared in poetry and in mathematics. It's a different old kind of thinking, but very lucrative if you know how to do it right. We have now, okay, let's have 4 minutes. So let's do something really quick. Everybody gets that? Good. Chris, isn't this better than the last time I went over? Yes, my teaching has improved. Yes, sir, because I spent the whole fucking summer doing math. It was very tragic. Okay, so now let's do this. We have an if. Then we have something in the middle. This I also went with RGB. On the pizza Saturday is happening again, 12. And I need at least 2 emails saying they're coming. Then I can get the big giant pizza from Costco. And it's only $9. Yeah, Costco. And I'm going to bring the Costco is beautiful. All right, now, in this thing, here we have some things. How did I do this? I call this side, if the hypotheses, if we assume something is true, then we can show that. So whatever goes here, what's this? This is the conclusion. Antecedent, and then what did I used to call that? Antecedent, consequent. Sorry, thank you. We want to show this thing. We want to prove that whatever statement is written here is true. So, right? And then how do we do that? So for instance, the statement could be this. Square root of 2, the proof that we don't have time to go over, is not a rational number. This is what we want to prove. And in order to prove that, this is usually at this level, this is the kind of theorems we're going to run into. One-line theorems with an if-then statement. We usually want to prove what is sitting here. Actually, every time we want to prove this. And here we need, what do we need here to prove that square root of 2 is not a rational number? You could just throw stuff in here. Brilliant, exactly, very good. So definition of the set of rational numbers, which was this thing. So we will be using this. Okay. What else? The idea that a fraction can be in a reduced form. What else? Shit, it just escaped now. What else? There's a third thing. Oh yeah, definition of an even number. What's the definition of an even number? Even number is always has 2 inside it as a factor. Give me any even number, and it will be a product of something and 2. So the even numbers are represented as 2n or 2k, where n equals 1, 2, 3, 4. These are the things that we will have to bring in to show this. So the usual proof for this is proof by contradiction. So we start at the consequent, but we assume so this is also another word is, this is the assertion that we want to prove. And so we say, no, we're going to say that square root of 2 is a rational number. If square root of 2 is a rational number, and I'm going to do what Jake just said, I'm going to apply the definition of the set of rational numbers, which is right here. Square root of 2, if square root of 2 is, so we assume, is this correct? No. We write what? That is the incorrect answer. Now we are saying, hey, look, 2 can be represented as a fraction m over n. And then we keep going. We will see you guys, thank you, Wednesday. Because they don't pay me enough to stay 1 minute late longer so that you can miss your next class.
I got about 45 minutes. 45 minutes, like ready.
Oh, you work? Where?
I'm a coordinator for an
Holy, after, oh, I see. That's where you get all your sicknesses and illnesses. Yeah. Hey, thank you guys. You are the loveliest class ever. Yes. I'll see you Wednesday, okay? Yes. All my my daughter's friends from Fairview, they miss classes. It's very bad. Okay. RGB, you're good? Super good? Yes, okay. All right. You will fall in love with math again. Yes, inshallah. I mean, that's a guarantee in this class. See you, Chris. Bye.